by checking the application of the sequential output. The application of sequential output will have 4 motors: 1, 2, 3 and 4. I have to run 3 motors at a time. So the combinations will be 1, 2, 3, 2, 3, 4, 3, 4, 1 and 4, 1, 2. 1, 2, 3, the 3 motors will be running at a time. The second sequence will be 2, 3 and 4, and third sequence will be 3, 4 and the 1, and the last sequence will be 4, 1 and 2. Okay, this will be the sequence I have to create: 1, 2, 3, 2, 3, 4 and 3, 4, 1 and 4, 1, 2. So we have 4 sequences, so the length will be 4. The length of the sequencer will be 4. Let's go. So in this, I have to provide the length of the sequencer will be 4. So I have to go for this. The N71 will be 1, 2, 3 and 4. This will be my mask, and the output will be provided with N7, 6. These are my outputs, and have to give the first output, the N70, 6 per 0, N77, 6 per 1, 6 per 2 and 6 per 3. These are my outputs, and I have to give the command as motor 1, and next will be motor 2, and another one will be motor 3, another one will be motor 4, and this will be my sequence. The application of the sequencer output will be, you can see on the runtime. Going. So by triggering, you can see by triggering, the first 3 motor will be running. Like in my sequence, you can see in the picture, first 3 motor 1, 2, 3 will be running. Next thing 2, 3, 4 will be running. And toggling again. See, 2, 3 and 4. Motor 4 will be running. On the next toggle, 1 and 3 and 4 will be running. On the next toggle, like I said, 1, 2 and 4 will be running. If I again triggering it, you can see we are back to the previous position. 1, 2, 3. This is the application of the sequential output. SQO I have to use with the N7 integer. In the N7 integer, the file will be N70. A mask I have to use as N75, and the destination N76. And the control I have to use an R6 control. Length as usual 5. Now we can run. Go for download. Everything will be in fast manner. So it's in the decimal. I have to change it to binary again, and I have to go to the hex. For everything, you have to make it as 0. Everything will be 0. Okay, back to binary. And I have to create a sequence first. I have to create a sequence. You can see I'm going to create a sequence from here, like the pyramid. 1, 1, 1, sorry. 1, 1, 1, 1, 1, 1, 1, 1. Okay, this is my sequence up to N74. and the mask will be everything is high. I'm going to change it to the XOBCD and change it to FFF or FF. FF means 8 bits will be high. Changing it to binary, you can see the corresponding masks are on, and N76 will be my destination. When I am pulsating, you can see I'm toggling. You can see the position is 1, means N71 will be fed to the output or the destination. And on the next pulse, you can see on the next pulse the N72 at the second position, N72 will be loaded to the output. You can see here. And on the next pulse, N7 third output, and on the next pulse the fourth one, and the next one the final one. At the final one, you can see that done bit has been appeared because the length is equal to position. And on the next toggle, you can see that will be cycling to the back position, cycling to the first position. It is 1 1. This is the first position. We cannot get the 0th position during the cycle. If you want to get the 0th position, you have to use directly give the number manually as 0. You can see this by bypassing this, we'll be getting the N70 right here, and that's it. That's the sequential output. Hello, today we are going to learn about the sequencer in L broadly. First file sequencer we are going to learn is the sequential compare, or else called SQC. So we can put an SQC right here. It's a sequential compare. Let's discuss about the block. It does have file, mask, source, control, length, and a position. So first thing first, we can put a file right here. I have the N7 integer file here. I have to use in file N7 integer. I don't have the other memories, so I have to put from the properties. The last will be N7 15. So I get the consecutive 15 memories. So the next thing, I have to put the length. From where to where I have to store. That is the length. Length I am using as 5. So the file will be starting from N70, 1, 2, 3, and 4. Total 5 memories. Next is mask. So 5 memories are already registered. Have to use the 5th memory. Sorry, already 0 to 4 is totally used, and the next one have to use as the mask, and then the source. N76 I am going to use as the source right here, and the control. Control means it's a register that will be storing the length and position and the miscellaneous data. That is called an R6 control. You can see here on the left side, this is the R6 control that will be storing all these data like the miscellaneous data as length, position, found, and enable like miscellaneous bits. So I have to use the R60 as a control. I have to put right here, and the length is 5. Position will be happening, or position we are getting through by pulsing here or triggering the feed to the sequential compare mode. And we are not done yet. We have 3 outputs. One is found, one is done, another one is enable. When the block is get powered, the enable will be on, and when the block is completed its cycle or the sequence, that position is equal to 1, 2, 3, 4 up to 5, the done bit will be triggered, and the found bit I will be expiring throughout the video. Next thing, have to use a contact. From here I am using an NO contact that will be powering up with I'm going to use a status bit. The status bit means I'm explaining the status bit because if you are using the status bit, a time-based status bit, have to change it to the binary. That will be pulsing or triggering the input in every 1 second. I'm using a good time base. Have to use the time base right here. I'll show you during the runtime how it is getting worked. The time base, you can see I have put a S column 4 bar 5 time base that will be on and off in every 1 second. That's it. And then I have to use, before the time base, I have to use an input also to control my inputs right here. I have to use another contact and have to use an input also. Here I just want to use an input and then have to run it. First verify the project, then download, save, and I have to run it. Now we are on the run mode. You can see the S5 S:4 bar 5 is pulsating in every 1 second. If you want to see that, you can go to the status bit right here. See, the bits are pulsating in every seconds, and some bits are in very high speed manner, some bits are in very low speed. These are the status bits, and this is the current scan. Everything you can watch it in the status data file. And next thing we have to go for this, we can go to monitor all this stuff in the N7 integer. So it's a sequencer, so we have to monitor everything in the binary, so not the decimal. Go to the binary, see all these N7 16 bits over here, N7 1, 2, 3, 4, 5 up to, and we can monitor. Okay, so this is the N7 integer, and I am going to create a sequence. This will be my sequence, like in the pyramid format, 1 and 1 1, like this. I'm making like a pyramid. This will be my sequence, 1 1 1 and 1. This is my sequence, and I'm making the mask, every mask as high, N7 5, everything I have to make it as high. That's an easy manner. This change it to hex or BCD, and the 5 have to give us FFFF. 1 F represents 4 ones in 16 bits, 4 4 4 4. So everything will be high, and hit enter, and I'm coming back to binary again. Now every bits in the N75 will be 5. 1 F notates the 4 ones, second one notates the another 4 ones, like that. Then I have to power up the input, the sequential compare. I have to compare a sequence. My sequence will be here in the N7 third, in this third memory, N7 third 3. This will be my sequence. So I'm making this N76 as N76 piecewise source, and I'm making it as 1 1 1 and 1. The same sequence have to provide here, and I'm going to run this. So toggle, and you can see the found bit will be high during the third register. The found bit will be high. It's going in a high speed manner, so that I have to watch it in the low speed. You can see the found bit will be only on when the third bit is high, or which is triggered by the third bit. So if you want to see it in a slow manner, I have to go to change the time base. I have to save this. Yes. Again, come again. So again, taking the float, not float, N7 integer. Read the binary, we can monitor all these steps. And now we can go for this. The found bit will be only on when the third bit is, or the third memory is carrying. It is 4111. It is 4 ones right here also. The sequence what I have provided here will be equal to the third sequence. When I am pulsating once again, or toggling once again, you can see now the position is 4 when I am toggling again. And you can see there is no down bit, because on the fourth position you can see it's 5 ones, and there are in our sequence that will be 4 ones, and there will be no found bit. And if I am pulsating again and again, the done bit will be on, because the length is equal to the positions. So the fifth position, you can see it is nothing inside the fifth position, so no found bit. That's it. And now we are going to do the next one, the next sequencer we are going to plan. We are going to do it next, which will be here, the sequencer. We are going to the sequential load. We are going to the sequential load. I am deleting this, and the sequential load, SQL, sequential load. same thing, same. The first thing you have to put the file. A file have to use and a source, control and a length. The source will be my sequence will be loaded from the source. So N70, I am using the N75 as my source, and the control as R6 control. R6:0. This is my control, and the length will be I am using as 5. Because I just used the N70. After that, I just used the N75, N70 to N74. They have 5 registers will be for the sequential, and we can go for the runtime. And during the runtime, we can go for the integer, N7 integer, and change it to the binary. And the sequence will load. From here, from N75, that will be loaded to the N70 and the next registers. So this is my N75 is my sequence. What I have providing here, that will be loaded to the next one. So I'm just using a decimal hexadecimal, making it as 0. So every bit will be 0, and I'm going to toggle it again, toggle back. On the binary, you can see I'm using 1 and 1. Okay, this is my sequence that I have to load to the N7 because on the single toggle that will be loaded to the first position number 1, and that has been loaded, and have to use these 2 bits also, 1 and 1. And this is my second sequence. On the toggling, you can see that is loaded to the next position. Okay, next position that has been loaded, and I'm going to add up one more on high here, and I'm going to toggle it again. See, the next position that has been also loaded. That is the sequential load. What I am using in the source, that will be loaded to the corresponding positions. The length and position will be stored in the R6 control. You can see the length and the current position will be stored in the R6 registers. That's why the miscellaneous